Hi there, in this video clip today I want to talk about the rates of reaction and the factors or the things that affect the rate of a chemical reaction. Reactions only occur, chemical reactions only occur when particles, and they can be ions, molecules, chemical compounds, formulations collide. And the second thing is they have to collide with sufficient energy for the reaction to occur. Just said reactants giving products. I'll write it in a longer format now. A plus B reacting to plus C plus D. Reactants, products, by the way, that sign means reversible. In theory, all chemical reactions are reversible, but that's not strictly true. The factors that affect the rate or speed of a chemical reaction are as follows. There's 5 of them. There is the surface area to the volume ratio. There is the temperature, temperature. There's pressure, concentration, and I'm going to put in a 5th one, which I'll explain how they work in a minute, is the presence of a catalyst. I'll come back to surface area to volume ratio in a moment. Temperature. Reactions occur when particles collide, so if I'm heating a reaction and there's A and B, and as I warm them up, they get excited. It's like if I stuck a Bunsen burner on your bum, you'd soon move, wouldn't you? So increasing the temperature increases the energy of these reactors, and they're more likely to collide. 2. Pressure. If I took, for example, at a piston, and I've put in gas A and B, and then I press that piston, which makes the volume smaller. Therefore, in the case of a gas, the particles are getting closer and they're more likely to collide. And reactions, I've said, occur when particles collide. The next one is concentration. Next one is concentration. If I took 2 test tubes, A and B, and in there I've tipped a solution of A, and in there I've got a solution of B. If this contains that amount of particles, and this contains that amount of particles, they react together. Because reactions occur, like I keep on saying, when particles collide. But suppose now I increase the concentration of the reactants of both A and B, and I mix them together. The greater the probability is of particles, I'm using that word particles, it could be chemicals, molecules or ions, the greater the chances of particles A mixing with particle B, reacting together, collision is higher. catalysts I'll come back to later on, but I want to look at this. The surface area and the volume of the reactants. I'm going to go through this slowly because it causes people a lot of grief. Let's take something at a reactant and suppose I say this is 10 units by 10 units by 10 units, length, breadth and depth. Let's calculate its surface area. It's a cube, it's got 6 sides, each side is 10 by 10 units and there's 6 of them. So therefore its surface area would be 60 units, let's just call it U. And its volume would be, and its volume would be 10 by 10 by 10 is 1,000. By the way, I can't count, sorry, that should be 600. 10 by 10 is 100, multiplied by 6, 600. So therefore, the surface area to volume ratio, I'm just going to cross out that, cross out that, cross out that, is 6/10, which if we're thinking metric, is 0.6. So the surface area to volume ratio is 0.6. Let's now take a smaller cube, 10 times smaller. There it is. And this time, instead of being 10 by 10, it's 1 by 1. Its surface area, there are 6 sides, each one is 1 by 1, 1 times 1 is 1, and its surface area is equal to 6, and its volume is 1 times 1 times 1, which is 1, so its surface area to volume ratio is 6. So by making the particles smaller of the reactants, I increase the surface area, you've just seen in that calculation, by a factor of 10. So if I made those reactant particles even smaller, the greater the surface area, and hence the greater the chances of collision. So that's the factors which increase the speed or rate of a reaction. It's common sense, if there's more of them in A and B, they're going to increase the rate of chemical reaction. And the final factor is using a catalyst. A catalyst is defined as a substance that speeds up, or I'm going to tell you this, slows down, but I'm not going to talk about the slowdown of reactions to start with. A catalyst is a chemical which speeds up the rate of a chemical reaction but remains unchanged at the end of the reaction. You tip in a bit of iron and it remains as iron even though it's speeded up. Now, how do they work? If I looked at a typical reaction profile, and this is the reactants react together to form products, and this is on a time scale, and this is the energy. Reactants react together to give me products. In that case, you can see that the energy of the reactants is greater than that of the products. However, life is not straightforward. Before the reactants can react to form the products, they need a bit of a kickstart. And this is what the profile, the energy profile, would look like. There is the reactants, there's the products. And before the reaction can occur, I have to supply a certain amount of energy called the activation energy for the reaction to occur. And what a catalyst does is it finds an alternative reaction route of a lower energy. So without a catalyst, the reaction profile would look like that. With a catalyst, it finds an alternative route of a lower energy. So rather than have an activation energy of that, it gives us a activation energy of that. And that is how a catalyst works. It lowers the activation energy by finding a alternative reaction path. So today I've explained how you speed up. By the way, the converse applies. If I wanted to slow a reaction down, decrease the surface area of the particles or the chemicals reacting, decrease the temperature, decrease the pressure, decrease the concentration, but they are the factors that affect the rate or speed of a chemical reaction.